Today, we're going to start a brand new topic, and that topic is called rational expressions. A rational expression is basically when you have a fraction and the numerator and or the denominator are polynomials. So you may have a binomial over a trinomial. You may have a trinomial over a binomial. You may have a binomial over a binomial. You may have a monomial over another monomial. It's a fraction where the numerator and denominator are both polynomials. It's called a rational expression. And we're going to do lots of things with rational expressions. We're going to simplify them, we're going to multiply them, we're going to divide them, we may even add and subtract them. The first thing we're going to do today is simplify. This is very, very important. It's just like simplifying a fraction back in junior high. You have a fraction, you have to make sure it's in simplest form. Everything else we do, all those other topics I talked about, multiplying and dividing and adding and subtracting, you have to end up making sure it's in simplest form at the very end, just like a regular fraction. So this lesson is very, very important. It's very easy as long as you can factor. If you can factor, which we spend a lot of time factoring, so hopefully that's something you're good with. If you can factor, this should not be that difficult for you. So how do we simplify rational expressions? You are going to factor both the numerator and the denominator. So take the top and factor it. Take the bottom and factor it. And then we're going to cross out any common factors. So anything that's common on the top and on the bottom, we are going to cross out once it's factored. But the first thing you have to do is factor both top and bottom. So let's look at some examples. 6x over 6x plus 30. So we have a monomial over a binomial. The first thing we have to do is factor. Can I factor 6x? No, you cannot factor a monomial. That's not possible. So if you can't factor it, we're just going to leave it. Now on the denominator, I need to factor out a GCF. Well, what's the GCF? It's 6. I'm left with x plus 5. Okay? Factor the numerator. I cannot do that. Factor the denominator, which would be take out the GCF. And now I can cross out anything that's common. So is there something common on top and bottom? Yes. I have a 6 on top and a 6 on the bottom. I can cross these out. Here's the important part about crossing out. You can only cross it out if it is being multiplied. You can only cross it out if it's being multiplied. You can only cross it out if it's being multiplied. Now, why did I repeat that 3 times? Because that's a very common misrepresentation. Lots of people get that wrong. You have to make sure you're multiplying. What do I mean by that? If we go back, 6 and x are doing what? They're multiplying. It's 6 times x. What is the 6 and the parentheses doing? They're multiplying. If I was going to read that, I would say 6 times the quantity x plus 5. So as long as I'm multiplying, I can cross out. So what's left on top is x. What's left on the bottom is x plus 5. Now, some people may say, well, why can't I cross out the x's? The x's are the same. Why not? We just talked about that. Because what is the x and the 5 doing? They're adding. You can only cross it out if they are multiplying. The x and the 5 are being added, they're being added, which means I cannot cross them out. You can only cross them out if they're being multiplied. So this is my final answer. That is simplified. Let's look at another one. 2x to the second plus 8x all over 3x plus 12. So in the numerator, forget about the denominator. Don't even look at the denominator. We are factoring each of these completely separate of each other. So just focus on the numerator. How can I factor that? I can take out a GCF of 2x. I'm left with x plus 4. Okay, now I look at the denominator. How can I factor the denominator? I take out a 3. And I'm left with x plus 4. I factor the numerator. I factor out the denominator. Now, is there something common I can factor out? Yes, they both have an x plus 4. I can cross them out because they're common. Now, if you're thinking, well, I'm adding, and you said I can only multiply. If I look at the whole binomial, this whole binomial, x plus 4, is being multiplied by the 2x. It says 2x times the binomial x plus 4. Same thing on the bottom. I'm multiplying 3 times x plus 4. So as long as I cancel out the entire binomial, it is being multiplied. So I'm allowed to do that. So I have 2x over 3. That is my answer. Our next example says 8x to the second plus 16x all over 32x. So we're going to factor both of these. Let's factor the numerator. I can take out an ax. I'm left with x plus 2. On the denominator, it's just a monomial. It's 32x. I cannot factor it, so we're going to leave it. Now, is there anything common I can factor out? Yes. I have an x and I have an x. Those x's can be crossed out because I'm multiplying. It's 8 times x. It's 32 times x. Now, the other thing I can do is I have an 8 over 32. I can simplify that fraction just like in grade school, in 6th grade when you learn how to simplify it. What goes into both 8 and 32? 8. So it's 1/4. So I can reduce the 8 and the 32 down to 1/4. Why? Because they're both coefficients. As long as they're coefficients, you can reduce them. So this is 1 x plus 2 all over 32. Or sorry, all over 4. Because I reduced the 8 and the 32. And 8 over 32 reduces down to 1/4. Now, because it's a 1, I don't necessarily need the 1. I could get rid of it, which means it's just going to say x plus 2 over 4. Both of these answers are the same thing. It doesn't matter which one you write. They both represent the same thing. Because it's a 1, I don't need it. Now, obviously, if it was anything else besides a 1, you'd need to keep it there. But because it's a 1, I can get rid of it. Now, I cannot reduce the 2 and the 4 because the 2 is being added. Remember, you cannot reduce it and or cross it out if it is being added, like this one. Now I have two trinomials, x squared plus 3x plus 2 all over x squared plus 7x plus 10. Well, hopefully we remember how to factor a trinomial. If it's a trinomial without an a, there's no a on top. Remember, don't even look at the bottom. We're just factoring the numerator. On the numerator, there's no a, so I'm looking for two numbers that multiply to give me 2, but also add to give me 3. And those numbers are 2 and 1. On the denominator, same thing. It's a trinomial without an a. There's no a, and there's no GCF I can take out. So I'm looking for two numbers that I can multiply to get 10 and add to get 7, and that would be 5 and 2. So I factored the numerator, I factored the denominator, now I can cross out. Is there anything common? Well, yes. X plus 2 and x plus 2. Those can be canceled out. So now on the numerator, I'm left with x plus 1. On the denominator, I'm left with x plus 5. Can I cancel out the x's? No, because I'm adding and I'm adding. Factor, factor, cross out what's common. Let's do one more. X squared minus 64 over x squared minus 16x plus 64. So let's factor the numerator. Remember, don't even worry about the denominator. Factor the numerator. How do we factor that? We can do dots. Difference of two squares. It's a binomial. I'm subtracting, and they're both perfect squares. So hopefully we remember dots. We get x plus 8. We get x minus 8. Take the square root of 64, and that's how I get 8 and 8. On the denominator, it's a trinomial without an a. I'm looking for two numbers that multiply to get 64, but add to get negative 16. So once again, they have to multiply to get 64, but add to get negative 16. And that would be negative 8 and negative 8. So now I can cross out. Now what's common? I have an x minus 8 and an x minus 8. Now, I also have another x minus 8. I cannot use this one x minus 8 to cross out both of them. Okay, it basically needs to have a partner it needs to match up. So I cannot cross this one out with both of these. I can do this one and one of the ones on the bottom. So now I have x plus 8 over x minus 8. Can I cross out the x's? No, because I'm adding and subtracting. Can I cross out the 8's? No. So simplifying rational expressions is very easy. Factor the numerator, factor the denominator, cross out what is common. As long as you are multiplying, you can cross it out. And that's simplifying.